Hey, and welcome to another dynamics physics video, this one on tightrope walking tension. Janet is to walk across a high wire strung horizontally between two buildings 12.0 meters apart. The sag in the rope when she is at the midpoint is 11.0 degrees as shown below. If her mass is 52.0 kilograms, what is the tension in the rope at this point? So, again, this is a dynamics problem, so we are going to be making a lot of use of free body diagrams and Newton's second law. Now, the first thing you need to see when you look at this problem is that Janet is stationary at this point. Okay, that means F net equals 0. If you are not accelerating in any direction, okay, that means your net force is 0, and that simplifies the problem to a huge extent. Okay, so Janet is stationary. So F net equals 0. Now the other nice thing about Newton's second law is that you can use it in the y direction and the x direction separately, and then combine the two pieces of information together to get, your solution. Okay, so if F net is 0, we can find her weight because we're given her mass. This turns into a really simple problem. Okay, so first things first, let's do our free body diagram. Okay, so instead of drawing her, I'm going to just draw a rectangle because I'm simple like that. And let's see, what forces does she have acting on her? Well, she has a mass, so therefore there's a force of gravity. So there's Fg. Now, there's tension as well. You see the rope. Something you need to recognize at this point in order to make it easier in future problems is whenever you have one rope, it doesn't matter if there's two objects at the end or one object. It doesn't matter. If there's one rope, there's one tension. Okay, so we are going to draw, we have one force of tension going this way towards this building. We have another force of tension going that way to this building. Symmetrical, right? Because she's at the midpoint. And we're given that angle, it's 11 degrees. So if you do your, if you remember from grade 8 geometry, if you do your Z pattern here, you get that angle to be 11 degrees as well. So I'm just going to draw that in. So that there is 11 degrees as well. This is 11 degrees. It's symmetry, right? So there's our free body diagram. Okay. Now I'm going to define my positive direction. I'm going to let up be positive. Okay. Now I jump into my Newton's second law. Now the difference here is I'm not just going to write F net equals ma. I'm actually going to do Newton's second law in the y direction. So in the vertical direction. So why don't I call that y there? Okay, so F net y equals may. Okay. Now, we've already technically simplified this, right? Because as I stated earlier, she's not moving. She's stationary. So her acceleration is 0. So therefore, 0 times any number becomes 0. So that part just disappears instantly. Now, in the y direction, let's take a look. We've got gravity. Gravity's already in the y direction. Okay, it's going down. We've got tension. The two tensions, they have components in the horizontal and vertical direction. So they have a y component. These are the y components, and their x components go like this, right? The two other sides of the right angle triangle. So here we've got an FTY, and we've got an FTY on this side as well. And they're both going up, okay? So F net y is equal to FTY plus FTY minus Fg equals 0, right? Because that's what we got earlier from the right side. Now, FTYs are going to be the same because she's in the middle. It's the same rope, okay? So it's got to be the same magnitude. So FTY, if you do your Pythagorean theorem, right, you've got your, actually no, not Pythagorean theorem, your SOHCAHTOA, right? We know this angle here is 11 degrees. Hypotenuse is FT. So therefore the y must be the hypotenuse times the sine of the angle, since sine reflects the opposite side. So FTY is FT sine 11.0 degrees. Okay, another FTY plus FT sine 11.0 degrees minus Fg equals 0. Okay, now we've got two of these here. We've got Ft sine 11 plus Ft sine 11. So I'm going to combine those and get 2 Ft sine 11.0 degrees. And I'm going to take that Fg and bring it to the right side. So that's equal to mg. Now I'm trying to find the tension in the rope. So I'm looking for Ft there. So let's isolate for Ft. If I do that, I'm going to get Ft equals mg over 2 sine 11.0 degrees. And at this point, it's simply a calculation, right? We know the mass, it's 52.0 degrees. G is 9.8. The bottom is simply an expression that turns into a number. Okay, so let's plug in our values. M is 52.0 kilograms. G is 9.8. Remember, the units for G can be expressed in meters per second squared and newtons per kilogram. So in this case, I'm going to use newtons per kilogram because it's going to cancel nicely with this. And 2 sine 11, I'll just enter that in my calculator. Make sure your calculator is in degrees when you do that. Okay. And when you calculate this expression out, oops, you are going to get 1335.37 newtons. Now remember, based on the original problem, we have to express it to the correct number of sig figs. Okay, so 3 sig figs, 3 sig figs, 3 sig figs. So I'm going to answer this to 3 sig figs. Let's scroll this up again. So if we round this to 3 sig figs, I'm going to express this in scientific notation. We're going to do 1.34 times 10 to the 3 newtons. And that is your force of tension. Okay, so that's it for this video, guys. I hope you enjoyed it. If you did, be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from me. I post every weekday at 12 noon, so be sure to be on my channel at that time to catch my latest video. See you guys in the next video, and I hope you enjoy the rest of your day.